Good day. This is Bennett, also known as Jeremiah. Today we're going to deal with a type of question that says for which values of x will f at x times h prime x be greater or equals to 0? If you want similar types of questions including other levels, the playlist is found at the end of this video. It is also found right here on the top right of the screen at the suggested video. Alright, let's begin. Alright, here is a situation. So, you are given these graphs f and g, and you're asked for which values of x will f at x times g prime x be greater than 0. So, what do you do? So, first of all, I want to show you something. So, you should take note from calculus that whenever your graph is increasing from left to right, whenever your graph is increasing, your first derivative is positive. But whenever your graph is decreasing, from left to right, your first derivative will be negative. So, whenever your graph is increasing, your first derivative is positive. Whenever your graph is decreasing, your first derivative is negative. So, going back to this situation, whenever your first derivative is positive, your graph is increasing. When it's negative, your graph is decreasing. Now, let's talk about how we deal with this stuff, right? Alright, so now looking at the question, notice that we've got f at x times g prime x. Whenever you've got f at x, you have to draw vertical lines on the x-intercept of f. If it was g at x, you would draw vertical lines on the x-intercept of g. And here we've got g prime. So whenever you see f prime or g prime, let's just say we have f prime. If you have got f prime, this time you draw vertical lines on the turning points of f. If you see g prime, this time you draw vertical lines on the turning points of g. So let's apply that knowledge. Let's just apply that. Let me just raise this. So notice that we've got f at x, right? So f is the blue graph. So we have to draw vertical lines on the x-intercepts of f. So we draw vertical lines. So notice this how it's going to be. Matter of fact, let me just draw solid vertical lines. So let's just draw solid vertical lines. So let's just make it a bit better. Okay, so something like that. Okay, so we draw vertical lines on the x-intercept of f. Alright, so now it also says g prime. So whenever we see prime, we have to focus on the turning point, right? So I'll explain why. But even if I don't explain it, you just follow the method. But I'm going to explain. So the turning point of g is at 1, right? So we have to focus on the turning point of g. So we draw vertical lines. So looking at these vertical lines, how many groups do they split the Cartesian plane into? Notice that we've got group 1, right, which is this portion, and then we've got group 2, right, and then we've got group 3, which is the small group over here, and then we've got group 4. So it splits the whole Cartesian plane into 4 groups, right? So now let's approach the question. So remember, whenever you see f at x or g at x, you have to draw vertical lines on the x-intercepts of the respective graph. If you see f prime x or g prime x, you have to draw vertical lines on the turning points of either f or g, depending on which one they say prime, right? So now we've got 4 groups. So now this is what you'll do. Notice this question. This question says the product, the multiplication of these two must be positive. So what is it that gives us positive? How can we get positive? We can only get positive if it is positive times positive or negative times negative. What does it mean? If this is negative, this must be negative as well. Or if this is positive, this must be positive as well. So this is what you'll do. Looking at each group, right? Looking at each group, let's start from group 1. What you'll do is that you'll check the y value of f, right? Because when you see f at x, it means the y value of f, right? If you see g at x, it means the y value of g. So now here we look at the y value of f. So in group 1, the y value of f, you just have to check if it's positive or negative. Notice, if it is on top of the x-axis, then it is positive. If it is underneath the x-axis, then it is negative. So it is that easy to check, right? So now notice at the moment, f is the blue graph, right? So in group 1, if you look at f, notice that f is on top of this line. So what does that mean? So it therefore means that f is positive, right? And then now we look at this part, g prime x. So all you'll do is just to check whether it's increasing or decreasing. So now we have to find out, is G increasing or is G decreasing? So notice that if you look at G, right, the pink graph, notice that it's going up when we move from left to right, so it's increasing. What does this tell us? It tells us that the first derivative is positive. Remember, when the graph is increasing, the first derivative is positive, but if it's decreasing, the first derivative is negative. So that is what you'll do. So notice that, let me just sort out something. Let's just do something. Okay, so notice that here we've got G increasing, right? And here the y value of f is positive. So does this fulfill the requirement? It does fulfill the requirement because we wanted it to be positive and positive or negative and negative. So it means that group 1 works, right? And then if group 1 works, obviously group 2 will not work, but let's just confirm. So let's look at group 2. Now notice that the y value this time is underneath the x-axis, right? So what does it mean? It means that it's negative. All right, so here we've got the y value as negative. Now let's check the first derivative of g, right? Is it positive or negative? So notice that g is increasing. So the first derivative is positive, right? So it means the first derivative is plus. So now notice that they are different. The first derivative of this graph is positive, while this graph, the y value is negative. So does it fulfill? It won't fulfill because obviously if you multiply them, it will give us a negative. We wanted it to be positive, right? So it means that it doesn't fulfill. We found out that group 2 does not work. Let's check group 3. So in group 3, notice the y value is underneath this graph, right? Underneath the x-axis, I mean. So the y value is negative, right? What about the graph? Is it increasing or decreasing? Notice that this time it's going down, right? From left to right, it's going down. So it's negative. Does it fulfill? Yes, it does. Because when we multiply them, the answer will be positive. So group 3 also works. So let's look at the fourth group. So in the fourth group, notice f is above the x-axis this time. So what does it mean? It means that f is positive, right? And then let's check g. Is g increasing or decreasing? G is decreasing, so g is negative. So does it fulfill? It didn't, just like the prediction. So the groups that worked were group 1 and group 3. So now let's describe their x values. So let's talk about group 1. Where does it start? Where does it end? Notice group 1, right? This group 1. Notice that group 1 does not have a beginning, right? There is no beginning of group 1. So it started an arrow. So meaning that it starts from negative infinity. So what you will do is that I'm going to show you an interval notation and also an inequality notation so that you choose your preference. So notice that we're going to say x is an element of, so it starts from negative infinity, right? Negative infinity, come on, I don't like this stuff. So negative infinity always has a curved bracket, right? So it starts from negative infinity. So it starts from negative infinity, and where does it end? It ends at negative 5, right? Notice it starts from negative infinity, it ends at negative 5. So it ends at negative 5. Now let's talk about the bracket. Should we put square or curved bracket? Whenever the question says greater or equals to, you'll put a square bracket because square bracket means greater or equals to, right? But if it was greater than only, you would put curved bracket. So that's how you determine. But as for infinity, infinity always has a curved bracket. So whenever you're done describing the first group and you want to describe another group, you will say or, like in probability, because we're using interval notation. So if we're using inequality notation, we would use or in words. So I'm going to show you the difference. I'm also going to show you this in inequality notation. So that's group 1. So now let's talk about group 3. So group 3, notice the beginnings at the x value of the turning point, which is 1, right? So notice we're only describing the x values because the question says for which values of x, right? So we describe the x values. So it starts from 1 until 2, right? So notice that it starts from 1 until 2. Square or curved bracket, you just copy the question just says greater or equals to, so you do this. So this is it. This is in interval notation. Let's talk about inequality notation. So in inequality notation, whenever the arrow points to the left, whenever there is no beginning, but there is an end, you'll just say it's less than 5. Notice less than negative 5 means that it can go as less as possible, right? So that's what you'll do. So you'll just simply say x is less than negative 5, right? But less or equals to, you just copy the question. So that's group 1. And then you say, oh, now notice that it starts from 1 and it ends at 2. So whenever there is a beginning and an end, you'll put the beginning first, it starts at 1 and it ends at 2. So you'll just put x between. So it has a beginning and an end. So whenever it has a beginning and end, this is how you do it. So you just copy the question as well. So this is interval notation, this is inequality notation. So you choose your preference. Alright, let's go for the next two levels. And these next two levels are the ones that are more common in the exam.
Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvement.
Alright, here is the next level. So you're given the blue parabola f and you're given the pink hyperbola h. And you're asked, for which values of x will f at x times h prime x be less than 0? Alright, so we draw a vertical line over here. So we draw a vertical line on the x-intercepts of f. So something like that, something like that. Okay, something like that. Alright, so now let's look at h. We know that when we see f prime, we have to draw a vertical line on the turning point of the graph, right? Now, the nice thing is that the hyperbola does not have a turning point. But we have a problem. There is a vertical asymptote. The horizontal asymptote does not play a role, but whenever there is a vertical asymptote, you have to consider it as one of the vertical lines. So you can choose to consider it as one of the vertical lines along with these other lines, or you can draw your own vertical line on the asymptote so that it can remind you that it is a vertical line that you consider. So you always have to draw a vertical line on the asymptote or consider the asymptote as a vertical line. That's if you will not forget that it is part of the vertical lines. So how many groups do we have? Notice that we have got group 1, group 2, group 3, and group 4, right? So now let's look at this question. This question says that their product must be negative. The only way to get negative is when we get positive and negative or negative and positive. So it means they must be different, right? So let's look at group 1. So if you look at group 1, the y value of f, right? Notice the y value of f is underneath the x-axis, right? The turquoise line. So it's going to be negative. And then you look at the hyperbola. Is it increasing or decreasing? Well, it is increasing. So the first derivative is positive. Now, the nice thing about the hyperbola is that notice this particular one is always increasing, right? So it's increasing, right? After the asymptote, it's still increasing again. So when it comes to a hyperbola, it's going to be increasing everywhere or it's going to be decreasing everywhere, right? So the hyperbola has two shapes. So this would be like the asymptotes, right? So we have the asymptotes over here. So let's just draw this one a little bit better, right? So whenever the hyperbola is shaped like this, notice that it's going to be increasing everywhere. But if it is shaped this way, it's always going to be decreasing, right? So the hyperbola is going to be either increasing everywhere or decreasing everywhere. So then you won't really have to worry about the gradient. So notice that here it's increasing, right? So the gradient is positive. Here, the y value of this graph is negative. So this one is positive, this one is negative. Does it fulfill the requirement of the question? Yes, it does fulfill, right? Because we want it to give us a negative. And in order for it to give us a negative, it must be positive and negative or negative and positive, right? So it fulfills. Now let's check group 2. So when we say f at x, we know that we have to look at the y value of f, right? So notice that the y value of f is above the turquoise line. It's above the x-axis. So because it is above the x-axis, it is positive, right? And then now when you look at this particular portion, it tells us that we have to look at the derivative. We have to check whether the graph is increasing or decreasing. Well, the hyperbola is increasing, right? Besides, remember, this particular graph is increasing everywhere. So we see that here it's increasing and here the y value is positive. So Does it fulfill the requirement? Well, it doesn't. It's supposed to give us positive and negative, or negative and positive. So the second group fails. All right, let's check the third group. All right, so now looking at the third group, let's find out. So looking at f at x, so the y value of this graph, is it positive or negative? Well, it is above the turquoise line, right? So since it's above the turquoise line, it's positive. And then let's check the pink graph, right? Is it increasing or decreasing? Because here it says first derivative, right? So it is increasing because it's obviously increasing overall. This particular hyperbola is increasing overall. So notice this is positive, this is positive. Does it fulfill the requirement? No, it doesn't. Let's go to the next group. So in the next group, notice that we were looking for f, right? So is the y value of f positive or negative? Notice that this particular y value is negative because it is below the turquoise line, right? So notice that f is underneath the turquoise line, so the y value is negative. So let's check the derivative of the other graph, right, of h. So is the graph increasing or decreasing? Well, it is increasing since it's increasing everywhere, right? So notice that the y value, right, notice that this graph is increasing, right, and the y value of this graph is negative. So they're different, right? Does it fulfill this requirement? Yes, it does fulfill the requirement, right? So group 1 and group 4 works. So now let's rather describe the groups, right? So let's talk about group 1. So where does group 1 start and where does it end? Well, group 1 has no beginning, but it doesn't end. So it means that it starts from infinity. So I'm going to describe it in both interval notation and inequality notation so that you choose a preference. So it starts from negative infinity, right? And always a curved bracket. So it starts from negative infinity until negative 7. So negative infinity until negative 7. And then we're going to say, oh, okay, fine, let's talk about the bracket. Is it square or curved? So notice that because it says less than only, we have to put a curved bracket, right? If it says less or equals to, we would put a square bracket. So that's how it is. So now let's talk about the final group. So notice it has a beginning, but it has got no end, right? So it starts from positive 1 and it has got no end. So we always have a curved bracket for infinity, right? And then here it's a curved bracket because of the question. So I've described it in interval notation. Let's also describe it in inequality notation. So notice that in inequality notation, this one will keep on being less than 7, right? Whenever it is not beginning but an end, you'll always say less than. So it's going to be x must be less than negative 7, right? And then you write all in words because it's inequality notation. And then let's talk about this group. This group has a beginning but no end. So it means it can get as large as possible, right? So it means that you say, oh, x must be greater than 1, right? So there's a beginning but no end. So there we have it. Let's go for the final question, which seems to confuse a lot of students. All right, here is the last level. Well, everything is the same except for this question. So this seems to confuse students because we are referring to the same graph. Just before we continue, if you are interested in knowing the prices of the tutorials, the video that contains the prices and the updated contact details just in case these ones have changed is found at the end of this video. So now they said for which values of x will h at x times h prime x be greater or equals to 0? So we need it to be positive, right? Greater than 0. For it to be positive, we want it to be positive multiplied by positive or negative multiplied by negative. So this particular portion, h at x, tells us that we must focus on the x-intercept of h. Now notice that the x-intercept of h is right here at the y-axis, right? So we're going to draw a vertical line right on the y-axis. So we draw a vertical line on the y-axis. And then now looking at this part, so this graph only has one x-intercept, right? H only has one x-intercept. So now, and by the way, we will not draw x-intercept on the graph of f because it's not part of the question. Matter of fact, sometimes we might have even 3 graphs on the same Cartesian plane. So we're not going to draw x-intercepts. We're not going to draw a vertical line on every x-intercept of the graphs, right? We're only going to draw on the x-intercept of the graph that appears in a question and that says h at or f at or g at, right? So here, because it says h at x, we draw vertical lines on the x-intercept of h, right? If it was f at x, we would draw vertical lines on the x-intercept of f. So now here, focusing on this part, h prime x, right? So when we see h prime, we look for the turning point, and of course the hyperbola does not have a turning point, but it is a vertical asymptote which we have to consider. So we have to draw a vertical line on the vertical asymptote, right? So there's no turning point, but there is a vertical line, so we had to draw it. Now we are done with the vertical lines. How many groups does this split the Cartesian plane into? It splits it into 3 groups. Notice we have group 1, group 2, and group 3. So let's talk about the approach, right? So now looking at group 1, h of x, we have to check the y value of h, right? So is the y value of h the pink graph, right? Is the y value of the pink graph above the turquoise line or below the turquoise line? Well, since it's above the turquoise line, it is positive. And then we look at the gradient. Is it increasing or decreasing? Well, it is increasing, so the gradient is also positive. Does it fulfill? Yep, it does. Notice it fulfills because the signs are the same. Now let's check group 2. So now in group 2, we're looking for the y value of h. Notice that the y value of h, which is the pink graph, is below the line, right? It's below the turquoise line, so therefore it's negative. And then let's talk about the gradient. Is it increasing or decreasing, right? Because this says h prime x. So notice that it's increasing, right? So the first derivative is positive. Does it fulfill? No, it doesn't fulfill. Let's talk about the dead group. So notice that the graph, let's check the y value because it says h at x. So is it positive or negative? Notice that the y value is positive because it is above the turquoise line, right? And let's talk about the derivative. Is the gradient positive or negative? Well, since it's increasing, the gradient is also positive. Does it fulfill? Yep, it definitely does. So now we have to describe these two groups. So I'm going to describe in both notations so that you choose your preference. You can even practice both if you want. All right. Talking about group 1, if we look at group 1, notice it has got no beginning, but it has an end, which is at the asymptote, so it ends right at the asymptote. So you tell them x is an element of, so it has got no beginning, it begins from negative infinity, right? And it has got an end, it ends at negative 4, so it has got no beginning, but it ends at negative 4, right? So square or curved bracket, well, the question tells us greater or equals to, right? So therefore we have to put a square bracket rather. And infinity will always have curved bracket. And since we're about to describe another group, we say, oh, if this were the only group that worked, we'll literally leave it like this and we're done. So we'll tell them, oh. So let's talk about the third group, right? So it has a beginning, which is at 0, but it has got no end, right? So it has a beginning, which is 0, right? Remember, it begins at the y value, y-axis, right? We draw a vertical line on the y-axis. And it has got no end. So infinity always curved. And the side we always have a curved bracket. I mean, we have a square bracket because of the question. So if the question said greater than only, we would put a curved bracket, right? If the question said greater than only, we'd put a curved bracket. But because it says greater or equals to, we have to put a square bracket. So let's also describe it in inequality notation. If you want, you can also practice both ways, right? Or you can choose a preference. So notice group 1 doesn't have a beginning, right? So since it doesn't have a beginning, it means that it can get as small as possible. So what you'll do is that you'll say x must be less than, okay, less than, so x must be less than negative 4, right? Because negative 4 is the boundary. So it can get as small as possible because the arrow points infinitely to the left, right? So it has to be less than negative 4. Then we'll say, oh, so now let's talk about the third group, right? So notice it has a beginning, which is 0, but it has got no end, meaning it can get as large as possible. So because it can get as large as possible, we'll just tell them that x must be greater than 0. And then we put the equal sign because of the question, right? We just copy the question. So this is it. One thing you have to be careful of is that if one of the graphs in the question has an asymptote, you always have to consider it, no matter which level it is. If you have watched my previous video, I dealt with other levels, right? So the playlist is found at the end of this video. So I dealt with other levels. So even if it's the other levels, no matter what level it is, if one of the graphs in the question has the asymptote, then you have to consider that asymptote. You have to draw a vertical line on the asymptote.
Alright, we have reached the end of this video. I've included a playlist of similar type of questions. If you enjoyed this video, please like the video and subscribe to my channel. Any questions you've got or any video you want me to create, please comment below. See you in the next video.